everything works. Our board is there. Nobody can stop me from that board. Okay, fine. So, topic is active noise control. So the reality is, I am a wrong person in the wrong activity. Why? Why, you know? Because only word which is controlled in that title has something to do with this entity, and I have no relationship with controls. Okay. So if I am saying something wrong, then you have to assume that I don't know control system. It's okay. But because I don't know control system, we cannot give up, no. So what I did is last semester I went and taught a control system course. First time in my life I taught a control system course. But then what students are saying, my control system is not the control system. Why, you know? Because I am a signal processing person. So for me, everything is related to signals, port 0. Control system also saying port 0. You are talking French, I am talking Italian. But about the same thing only. So then I understood that control system is signal system part 2. And we should not call it control system. Okay? This is that. So my control system will be a signals and system control system, not the control. Okay, this is that. Fine. Now the question is, what is the topic? What is active noise control? What do you mean by that? What do you mean? What is active noise control? What is active? Are you active now?
Yes.
Some noise is there. There. What is active noise control? What do you mean by active noise control? That is first. Then why is it in this FDB? That is the second question. Yeah. What is active noise control means what? You heard this word active noise control? Yeah. ANC every day you are hearing ANC. Correct? Correct? Yeah. What is that? What is active noise control? What do you mean by active noise control?
Might be the noise is varying.
Eh?
Might be the noise is not constant, it is varying with respect to time.
Okay. Do you have a product which has an ANC? You have a product which you has an ANC? Even boat is saying ANC. They have this advertisement, boat ANC advertisement. Right? So, right now I have a noise which is produced by that AC, and I want to talk. You are more disturbed by that sound than my sound. So that means there is a noise, and I want to cancel the noise. What will it? Is it a control problem? Yes, it is a control problem. I am controlling the noise. But the problem is I cannot switch off the AC. So I cannot control the source. Source cannot be controlled. But I want to control. This is the problem statement. So what to do? What to do? Because I cannot switch off the AC. I don't know how AC is going to work. I don't have any idea about what is the control system of the AC. I don't know that. My objective is that you should be able to listen to my whatever I am telling peacefully without that disturbance which is coming from there. That is the objective. So what should I do? What should I do?
Increase your voice sound.
Good idea. That is one solution. What solution? Where we are increasing the SNR. Correct? Because noise power anyway I cannot reduce. So increase the signal power. Understood? But the problem is I have a limit on my signal power. Signal power is limited. So I want normal speaking signal power, and then also you should be able to hear. So what to do? Reduce noise power. Correct? Signal power is not in my control. Can I reduce the noise power? That is it. That is the idea of noise. So normally what we do is that when you go to a seminar hall or some theater or somewhere, you will see so many things on your ceiling, so many things on the wall. Correct? You see this dot, white dot things on the ceiling, and so it looks very weird only. It doesn't look beautiful. Correct? But then also they are necessarily putting it. Why they are phoning? So those are sound absorbers. Those are passive noise cancellation methods, where there is no algorithm, there is no control system, there is no filter, nothing is there. It's a mechanical device which is going to absorb some sound and reduce the reflection so that you will listen better. Correct? Why you are not able to listen better here in this room? You know why? When I say hello, how are you listening to the hello? I said hello. You heard it? Heard it? How did we hear it? So one signal came directly to the ear. Some signal hit the floor and hit you. Some signal hit the board and hit you. Understood? So many different signals are going to hit you and you heard this hello. This is what is happening. Correct? Now what we are saying means, if too much of that signal is there, you will what? Feel the echo of the sound. So I want to have minimum reflections. So I do this passive noise cancellation. Understood? But here what we are talking about is active noise cancellation, means kill a sound with a sound. Means you have a noise which is generated from there, you generate another noise by yourself, and then you run a control algorithm such that the noise is reduced. This is the objective. Okay, fine. So I have to fine. I think you should just check it and this will not move here. Here. Yeah. I think what we should do. Your phone is working. Your phone is working. So. Is there any app?
Yes, yes. You can directly.
Yeah, I am just going to YouTube and
Yes.
sound will come.
आप ज़्यादा घूम रहे हो डिस्टर्बेंस कर रही है
The expression, "you can't unring a bell," means that once something has been done, it's impossible for it to be undone. But that word impossible, it's not one we like. The Kalewa bell its sound can be heard across the surrounding neighborhood. In this experiment, GE engineers will be using sensitive acoustic equipment to cancel out the sound of the bell. We'll be using technology similar to that used in our subsea acoustic leak detector. This device carries special sensors that can pick up sound wave vibrations in the water and identify potential leaks. But today, we'll be putting this technology to a very different use. We're going to measure the acoustic properties of the bell, then produce a sound with the same amplitude but an inverted phase. We'll play this inverted phase through these speakers. The two sounds should cancel each other out to create a quiet zone. This process is called destructive interference. We'll place a sleeping baby in this quiet zone. People outside the zone will hear the bell, but if the experiment works, the baby won't be disturbed.
That is active noise cancellation. Because the sound was produced, the sound is heard by everybody else, but the baby did not hear the sound. And why did the baby did not hear the sound? Baby can hear because normally the baby is getting disturbed by that bell. But today the baby did not get disturbed by the bell. Why the baby did not get disturbed by the bell? So what you saw is behind the baby there were these 4 speakers which were put. And near the baby there were some mics which were put, and they are running a control algorithm. You can call it control algorithm. They are running a signal processing algorithm to cancel or reduce the noise level around the baby only. The algorithm is not cancelling the entire sound. The bell is still running. Other people will still hear the bell. But only around the baby, the algorithm has reduced cancellation, reduced noise. This is the idea of active noise cancellation, where one sound has been cancelled or and the power has been reduced by producing another sound. In simple terms, it is like a destructive interference, sine wave, but sound doesn't behave like that. Understood? This is the idea of active noise cancellation. Is that clear? Because this video you cannot never forget. You cannot forget. Whatever the even if you want to forget, you cannot forget. Okay? Understood? This is a little bit of dramatization of the algorithm. It is not that complicated, like what they are saying. You don't need to come with the train and do all these things. Okay? But when G is doing, it has to be theater. Okay? Fine. So what is the use of it? Big use is noise cancelling headphones. Noise cancelling headphones. Bose, Sony, even Boat, they have this noise cancelling headphones. What does noise cancelling headphone do? Should I buy a noise cancelling headphone? Is it cheap? Is it costly? Costly? Yes. But Bose headphone is 20,000, 25,000. Sony also 25. Correct? Boat is like 5,000. Yeah. Why so much money is there, and why somebody should buy it? Why somebody should buy it? I will give you a use case. So you are listening to music and you are going in a train. What will you do? You don't want to hear the noise of the train, so what will you do? You will use search approach. That is a solution, correct? We increase the volume. So that means a higher amplitude sound is being played to me, but I don't feel it like higher amplitude because there is significant noise outside. So I am getting exposed to significant noise just by listening to music inside a noisy environment. So I am highly likely to get a hearing problem. Because what WHO is saying is that 50% of young adults will have a hearing loss because of recreational hearing, not because of bomb blast or some machinery or something like that. Only because of recreational hearing of music and other things, people, 50% of the population is going to have a hearing loss, and they are calling it the new diabetes. I am not calling it. WHO is calling it the new diabetes. The hearing loss is the new diabetes which is going to come soon. But now suppose I am using a noise cancelling headphone. What has happened? The noise power has been reduced. So I need to play this sound only at a normal amplitude or even lesser than normal amplitude because even the other background noise has been reduced. I am more likely to retain my ear for a longer period. So there is a health benefit associated with the noise cancelling headphone. Is it so? So you are giving money to gym, you give money to headphone. Buy a headphone. So this is the classic application. Classic application of active noise cancellation is the ANC headphones. Bose is the pioneer in this, but now other players are there. Sony is very good in this. That is one major application of ANC. Then headphones, Qualcomm for 35 and Sony one. Then this has come in cars. Cars in the sense it's called Endeavour 2020 onwards model. There is noise cancellation inside. What they want to cancel inside it? Why do we need noise cancellation inside a car? So they want to cancel the road noise and engine noise, so that you will have a comfortable by producing new sound inside of the cabin, which will try to cancel the road noise and the engine noise. This is the idea we have. Now what we want to understand is what is the control system of this and how I can develop algorithm for this and how I can experiment and see whether my noise cancellation is happening or not. This is our okay. Till now what we have said is why I should listen to me. Why you should listen to me is what we have told. I have not started my action session. So now you listen to me. Okay, clear? Now I have what I have done is I have simplified the problem into a very simple noise cancelling problem where I am saying I have one noise source which is there. That noise source can be this AC. AC is producing sound because of the air and because of the compressor. If there is a compressor outside, that is also giving me the sound. So the sound inside is proportional or related to the sound which is produced outside. Correct? Fine. So what I can do is that I have a noise source. That is what is the first case. And I want a low noise source to be created. That means noise source I cannot touch because noise source is not in my control. But some sound is coming inside. I want to create a low noise source, maybe around this chair only, maybe in this room, whichever zone you are going to define. This is the objective. So our requirement is what? Our requirement is there is a noise source. Noise is going to come from here. I want a low noise to be created here. This is our requirement. Now I am seeing how I can achieve that. Now from the baby experiment, what do you know? That if I want to cancel that sound, because energy has already been produced, I may have to produce some other energy to cancel that sound. That means some sound has to be created. Who can create the sound? Loudspeaker. That means one loudspeaker should be there. So what I did is I bought one loudspeaker and I connected somewhere in this tube. Okay. This I understood. So what are the, you have to go step by step for this diagram. First step is there is a duct, there is a tube through which sound is coming from outside. Then I have a noise source here. I want low noise over here. And now I know that if I want to cancel, I should create some new sound. So I bought a speaker and put it on the in the tube. Fine. Now what all I need to know? I need to know what type of noise is coming from outside. Correct? Because I have to cancel based on what is coming. No? See, if you remember in that bell experiment, they connected something on that bell. Some sensor was connected on the bell. That sensor is a vibration sensor because sound is proportional to vibration. No? Correct? So instead of putting a mic there, they put a vibration sensor on top of the bell. So I should have some idea about the nature of the input signal. So in our case, because it is sound, I will put a mic outside of my room, near the compressor. That mic is the reference microphone. So that microphone is my reference microphone. Understood? So you have a noise source, you want low noise to be there, you have a duct, so you added one speaker, you added one reference microphone. Understood? This is how you are developing the problem. Nobody told Bose that this is how ANC is going to happen. By thinking they have developed that this is how it is going. Okay. Fine. Then I should also know how much is the noise level around your ear. Because that is what I should reduce. Because if you are only sitting here, I want noise to be cancelled only here. No, I don't want to worry about noise here. Correct? So I should have a measure of noise around your ear. How will I measure noise around your ear? Put another sensor. Which sensor? One microphone. That is the error microphone. Where I should put near the low noise zone. Because I want to measure whatever is the level of noise cancellation which is there. So I am putting a second. Understood? Now you know why I have two mics and one speaker. Is there any confusion on that? Why I have two mics and one speaker? Why I have two mics and one speaker? Yeah. Why I have two mics and one speaker? It's very costly. The speaker is costly. Mic is again costly. Why unnecessary I buy two mics and one speaker? One is to know what type of noise is there. One is to know how much noise, what is the level of noise which is cancelled. And one is speaker is to produce the noise. Fine. Now the second question is, what should the speaker do? What should the speaker do? Produce some sound. Based on what? Input. Reference. Correct? That is why I have got a controller. Now it is becoming a control system. I have a controller which is going to drive the speaker. What is going to drive the speaker? The controller is going to drive the speaker. Correct? Correct? So the controller output is given to the amplifier and it is given to the speaker. Correct? And then what should the controller take as input? Outside sound. So that's why outside sound is given as input to the controller. And the controller should update its poles and zeros. Update its poles and zeros in such a way that what should happen? Controller should update its poles and zeros in such a way that what should happen? Noise is cancelled. That means what signal has to be modified? So what I am saying is, you put a microphone, measure this, give it to a controller. Controller is some pole zero diagram. Finally, it is some pole zero diagram. Given it to the pole zero diagram, that means the signal is modified and played through the loudspeaker. But where should I move the pole and zero here? I should move in such a way that this error signal is getting reduced. Or I can say this E of n has to be reduced. Or a square of the error has to be reduced. Like in a machine learning problem. this problem an optimization problem? What is optimization problem? Give one example of an optimization problem. Maximize marks is an optimization problem. Is it not? Because I am doing so many things to maximize my mark in the course. So that is an optimization problem. Here my optimization problem is minimize error square or some function of error. Minimize error square. So what I am doing is I am trying to change my controller or control my controller in such a way that error square or the signal level near your ear is to be minimized. This is the problem. Now the question is, what is the algorithm and how will I know the algorithm? Is the overall problem statement clear? Is the overall problem statement clear? Is the overall problem statement clear? 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 Sure? Okay. Now how will I decide the control? All of the control system people. So you tell me how will you decide the control? So all of you have taught control system. Nobody has taught control system. Nobody has studied control system. Nobody has heard about control system.
Two signals should be there. One is from a reference that is being cancelled out, and the second one that is actual that is coming from the
Measure of error.
that error.
Error.
That should be compared,
That should be there.
and what should be the whatever maybe the error is there. Based on that, that controller will generate some signal that is in antiphase with that frequency of that error.
So if I am able to write an expression for E of n is equal to something which is a function of I will explain you what it is. What did I write? I said what is my objective? W is the unknown parameter in the controller. W is the unknown parameter in the controller. Unknown parameter means if I consider it as a filter, this structure we have seen. This structure we have seen somewhere. What is that structure? What is that? There is some delays, some multipliers, and some adders. What is that fellow doing? What is this fellow? I can have some multiplier values. 2, 3, 2 are multiplier values. What is that block doing?
It's multiplying the gain directly.
Increasing the line.
It will increase in the amplitude of that signal,
Increasing the amplitude.
of the signal by that factor.
Okay. Then why do we need delay? You can just put an multiplier. Why did I put delay and then multiply and then add?
The previous
There is a
value,
delay, there is a multiplication, and then there is an addition.
previous
Previous value is used.
yes.
Why? Why? This is a filter. I mean the signals and system filter. This is a filter. Can I say this is a filter? Because if I give hello to this system, I will not get hello. I will get something else. Correct? Because this signal, the signal hello, is going to be modified by this filter to give an output. different output. Understood? So let us assume that this is the controller. Can I assume that this is the controller? Yes? Where this vector means this W of n is equal to this vector 232 vector is what is deciding how my filter is going to behave. This 232 is going to determine how much my loudspeaker is going to produce output. Correct? So if I can somehow modify or change the W, what will happen? Loudspeaker will produce different type of sound. Will it not? Will it not?
Yes.
Now, if I formulate an objective or an optimization problem such that I find such that I find W, such that I find for what value of W will what's it there? What's it here? Yeah. Fine. For what value W? For what I am not disturbed. Okay, I am okay. Okay. Don't take it otherwise. Yeah. Just to make others up, not you two. Others up. So what are we saying? What are we saying? We are saying by changing W value, you are able to create a controller. Am I able to create a controller? Yes. Because when I have 232, it behaves like something. When I have 342, it behaves as something else. When I have some other random number, it behaves differently. That means I am able to design filters or controllers by having different values of W. Can I say? Now, if I formulate this entire problem as an optimization problem and say, find the best value of W, find the best possible value of W, which will minimize error square, what will happen? You getting my point? What I am trying to say? I am trying to say, what is the best possible value of these multipliers, which will give me minimum value of the error square? That can cause noise cancellation. Correct? Because if error square is minimized, that means the actual sound around your ear has to be minimized. How? By producing some new sound. Who will produce a new sound? Loudspeaker will produce a new sound. How will loudspeaker produce a new sound? Because the filter is going to push something onto the loudspeaker. This is the idea. So, is it clear? That is the formulation. That is the formulation. So, I should be able to write an expression for E in terms of W. I should be able to write an expression for E
The function
in terms of. If I am able to write an expression for E in terms of W, then I can do minimization. Now, can I write an expression for E in terms of W? That is the question. Can I? Where is W? This is W. Correct? This is W. Can I write what is the relation between W and E? That is what I want to write. Can I write? Okay. What is the relation between X and Y? Can I write relation between X and Y? What is the relation between X and Y?
Then 2x minus 1.
2 into x of n plus 3
minus
into x of n minus 1 plus 2 into x of n minus 3.
is equal
That
to
is
y.
the relation. What is that relation called?
Input output relation.
Input output only. What is that? This convolution. This is just convolution. Correct? Correct? Linear convolution only. So I can say my output here W, sorry, Y is equal to can I say x convolved with is this W can keep on varying. That's why I just put N. N means time instant. So I know the relation between X and Y. That means I am able to write an expression for Y, which is equal to X convolved with W. X convolved with W is my Y. That is clear. But now the question is, what is the relation between W and E?
That should be either plus E of n or minus E of n with this equation.
Because finally we are going to minimize E square, so it will not have any problem. Because we are doing E square minimization. Okay, E minimum value is minus infinity, no? So there is no minimum value. Now, what is the relation between W and or Y and E is what we have to find. What is the relation between Y and E? What is the relation between Y and E?
Difference of input and error. Error signal.
I did not get some. Yeah. What is this one?
Difference between input signal and error.
This one and this one.
That will output.
No, no, but this signal also contains signal which is coming from outside. Understood? Because if I put a mic here and say hello, that mic does not contain hello. It contains hello and then something. So the mixture is measurable. Your sound is not measurable independently. Understood? So now I want the relationship between Y and E. Now it is a full control system problem. Now it is in your language, not in the signal system language. It is in your language now. What is the relationship between Y and E? What is in between Y and E?
E should be there with x. X minus E or x plus E.
X and W.
In bracket x minus E or x plus E. In that.
Which one? This one.
That means xn.
Ah,
That contains x minus E or x plus E in one single bracket. Then that is multiplied with W. Something.
Minus EN.
this is not multiplication. It is a convolution.
Okay.
So X of n is a signal. Signal is convolved with the impulse response from signal system to get an output because it is linear and shifting distance. So you got an output Y. But that is not going to solve my problem because I want to know what is the relationship between Y and E. For example, suppose start with I switch off this. Then what is the relationship between Y and E? Because now I switched off the AC, so no sound is coming from here. Whatever E is going to be there is only due to Y passing through this. What is this? That is a system. That is a system. Correct? It is a system. What is that system? System has an amplifier, a loudspeaker, some air in between, and a mic. That is the system. But what is the input and output relationship of that system? How do I know? How do I know? Because I don't know any equation of the loudspeaker. I don't know any equation of the microphone. I don't know any equation of the air in between. I don't know. But I am asking you, for this physical system, what is the relationship between the input and the output? So whenever you have a physical system and you need to find what is the relationship between input and output, what you should do? You should do system identification. What is system identification? Modeling. Modeling. Correct? Finding the transfer function. Means, if I want to solve an ANC problem, step number 1 is that you do a modeling. which is going to behave similar to that of the
Physical one.
physical system. This is called system identification or modeling process. So step number 1 is a modeling process. You got my point? Okay? How will I do modeling? How will you do modeling? This is system. So this is an ADC, okay? You read it as ADC. This PAC is not correct. It is ADC. What is this diagram and previous diagram same? Some part is same.
Yes.
DAC, speaker, path, mic is same. That is a system. So I want to create a model of that system. So I formulate another optimization problem where I say you generate a random signal, play it through the actual system. What will actual system produce? Actual system will produce some output. Play the same signal through the model. What is the model? Some filter. This type of a filter where I will assume that the multiplier values are all zeros or all zeros or like exactly like we do in neural network. That is what I am trying to say. Okay, exactly like what we do there. So you have a physical system, you play some sound, same input signal you play through this model. This model is a filter, that type of a filter where multiplier values are zero or unknown or random. What will that path produce? Some other output. Understood? Physical system has some output, model has some other output. Understood? If they want to make them same, what I should do? What I should do? Means what I want the system's response and the model's response to be similar. How can I make them similar?
Generating reference.
Eh?
Generating reference signal.
In this setup, how can I make them? I want the B and Y to be similar or as close as possible. What I should do? I should do some learning. Learning. What type of learning is this? This is a supervised learning. Can I say this is supervised learning? Because you have a supervisor or a teacher available, and we are trying to make the student behave like the teacher. Correct? As teachers, what we do? What we do? We want to make the student similar to us, not better than us. Correct? Because only what we know only can be taught now. So the student theoretically can only be as best as we. He cannot be better than us, as per theory. Correct? Understood? So there is a supervised learning happening. That means I need to again do a adaptation of the controller. Which controller? The model, which is the filter, such that this error square is minimized. This error square is minimized. You can imagine that this is exactly a neural network function approximation problem. Function approximation, you do exactly the same thing only. But here everything is linear, nothing is non-linear. Okay. So what we are saying is you do that indexation. Okay. Now if I do that indexation, what is that model? This model is this. This is this. Where instead of 2, 3, 2, I have mentioned A0, A1, etc. A1 vector I have created. Just because I want to generalize it, I have created a vector. That vector is given by this A. What is this X vector? X vector is X of n minus 1, etc. What is X vector? So these are the two vectors. And what is the Y of n? Y of n is what? Y of n is what? Output of the model, which is input convolved with that multiplier, which is also equal to A transpose X. Is it A transpose X? What is the output? 2 into this plus 3 into this plus 2 into this, add them together. That is this same one. So I am able to write an expression for y here. Okay. I will come back again, but let's see if something you are able to understand or not. This is all simple only. But there is one very big point I want to say, that you don't need to study any of this. Otherwise also you don't need to study any of this. But there is one critical point which I want to tell you. So I am defining a function of error. That function of error I have defined as e square. E square. Correct? But I have put an e around that e square. There is a capital E, and then inside that I have put the e square. What is the meaning of that?
Expected value.
It is the expectation of e square. Expectation. What is the expectation of e square means what? Expectation is what? What is expectation? Expectation is what?
The exact
Ensemble mean.
that we need.
Correct. Something like that we can assume for the time being. So expectation of e square is the objective function which I have to minimize, or the cost function which I have to minimize. Is that clear? Can I now write e square as the second expression? Because e is d minus y. So e square is d minus y square. So d square minus this minus this. No problem. First line, anybody has problem with first line? First line is okay? First line is okay? Fine. Now if you see, if this is just a reorientation only, I will come here then. If I see here, when I rearrange it, I have a term called expectation dx. See, there is no example in this, so you don't have to worry if you don't understand. Okay, okay. But if you understand, you can do so many things. Okay. What I am saying, I have a term called expectation of dx. What is d and what is x? What is d and what is x? This is d and this is x. Input and output of the system. Input of the system is x, output of the system is d. Expectation of xt means how correlated are the input and output of the system, which is called cross correlation. Cross correlation means cross correlation between two signals. Which are the two signals? X and D. So I am defining one term called cross correlation, where you can imagine that as how related are X and D. Okay. So suppose I have a barrier in between, but this mic is picking up some other sound. So what is the correlation between X and D? Got my question? Got my question? So right now what I am saying is D is fully produced by X. So D and X are correlated. D and X are correlated. Okay? There is a finite correlation between D and X because D is produced by X passing through something. Okay? Now I am saying there is a barrier in between. So whatever sound is produced by the speaker is never reaching the microphone. But some other signal is coming because mic is there, it will pick somebody else talking also. Correct? So now what is the correlation between X and D? Is D anywhere related to X now? See what am I saying? I am saying there is a barrier here. So this sound is not reaching here, but this mic is picking some random sound. So this D and this X, what is the relation? No relation. No relation. there could be a situation where x and b are uncorrelated, but if suppose the barrier is porous, like this, somebody is shouting there and we are able to listen here. So porous, what will happen? X and b are finitely correlated, but not fully correlated. Understood? So we are defining the most important term of this lecture, which is correlation. Correlation. Correlation means two signals are there. Are they related or are they not related? That is the simplest meaning of correlation. Okay. Fine. Now, see this expression, expectation dx is what? Cross correlation. Correlation between what and what? The d signal and the x signal. Then I am defining a new variable t. So the variable t in this entire expression is the cross correlation vector. This is called the cross correlation vector. What is the meaning of cross correlation vector? How related is this signal x and signal d? In a normal case, fully related. Some cases slightly related. In some cases not related at all. Is that clear? Fine. Now you have here another term which is expectation of x transpose. X and x transpose means I and myself. Am I correlated with myself? Yes, I am correlated with myself. So that is called what correlation? Earlier was cross correlation. Now this is what correlation? It is there in second year BTech. This is autocorrelation. Understood? Auto means I am myself correlated. So x and x. So I am defining another term called autocorrelation. It's called autocorrelation matrix because there are two vectors which I am calling it R. So my entire objective function is now given by this last line, which is some expectation of d square plus some p term plus some a square r term. Now what is my objective? Find the best possible value of the w which will minimize this. In terms of w means a is a vector, a is the unknown vector. Okay. So instead of w there, this is a here. Fine. So what is the nature of that equation? If I plot that equation, how it will look like? It is an a square plus a plus something. Can I see that last line you see? Do you see an a square there? A is there. Last term is a square. Next term is a. First term doesn't have a. So is it a quadratic equation? Is it a quadratic function of a? Can I say? Yeah. Correct. So this function is a quadratic function of a. But what is the dimension of a? In our example is 3 dimensional. Suppose I say a is 2 dimensional. Suppose I say a is 2 dimensional. A is 2 dimensional means what? There are only two ways, a0 and a1. Correct? a0 can take any value, a1 can take any value. So for any combination of a0 and a1, there is this function which is there in this room, which has what shape? Which has what shape as per the equation? Which has a paraboloid shape. Why paraboloid? Because it is a quadratic function. But it is a 3-dimensional paraboloid because there is a one way going in that line, another way going in this line. So you will see that there is a paraboloid in this room, like this, which is either on the floor or above, we don't know, somewhere in the room, or maybe here somewhere one paraboloid is there. That is what that fellow is saying. That means that parabola will have a minimum point. What is the specialty of the minimum point? Derivative of the cos function will be 0. Correct? So if I take derivative of phi with respect to a and make it 0, what I should be able to get? What is the minimum point of a0 and a1, which will give the best possible model? This is the best possible model. Correct? So what I could do? I could take derivative of this with respect to a and equate it to 0. You will get an expression for a. Okay, you will get an expression for a. That expression, this is the derivative. You see, the derivative is 0. So I can say minus 2p plus 2r is equal to 0. So my A optimal is given by R inverse P. R inverse P is the best possible value of the model. This is called a Wiener solution. What is it saying? What is it saying? That the best possible model you can find. The best possible means the best possible theoretical model you can find, or the filter which is equivalent to the path between the loudspeaker and the microphone is given by this equation called R inverse P. That means this is dependent on autocorrelation and cross-correlation. Autocorrelation and cross-correlation is dependent on P. How X and D are correlated. How X and D are correlated. This is the most important. Okay, this is. You got some idea now? Some idea now? There is system, there is model, there is correlation, there is autocorrelation, there is cross-correlation, there is system identification, and then everything goes into NC. Understood? So by doing this process, what I could do is I could replace that diagram, first diagram, by this diagram, where the path between the speaker and the mic has been replaced by a system. System means another filter. The path has been replaced by a system. The path from the first mic to the second mic is also replaced by another system. Whenever you are making algorithms for physical systems, step number 1 is do a model and convert the entire system into an electronic system or an electronic equivalent, or you will have to do system identification. Now what has happened? Your physical system which was available, which had duct and mic and loudspeaker and all of those things which we don't understand, has now been converted to an entirely electronic diagram which contains only filters. P is one filter, S is another filter, this A is the controller, which is another filter. So there is a combination of filters which have been created over here. Now what I should do? Run the next optimization, because we already did one E-square minimization to find the optimal value, to find systems. Now you are running the ANC's E-square minimization. If you do this E-square minimization, you will be able to find what is the update rule for updating the controller values. Okay, fine. So you can pause it.
Yeah.
We are doing controller design with physical systems. Whenever you want to design controllers for physical systems, you need to create models. Because otherwise you cannot write the algorithm. Because you have to write the expression and take derivative. You can't write the expression because I don't know how AC behaves. I don't know how the physical system behaves. But I know how models behave. Because models are filters. Models is within the domain of electrical engineering. System is not in our domain. System is a chemical engineering system or a mechanical engineering system which we don't understand. But we understand systems. So we will model it and use it, but not the actual system. Okay, that's what I am saying. So what we have done is, we have a physical path and I want to create a model of that path. So I generated some random signal. Random signal I played through the loudspeaker, put a mic somewhere, measured the output, I got some value. The same input is given to a filter with some random rate value, you get some output. So you have a difference between the output of the actual physical system and the model. You try to minimize that cost function, and we know how the cost function is going to be minimized. The final, the best possible value of the model is what? Given by R inverse P. R inverse P. Because R inverse is the autocorrelation matrix inverse and P is the cross correlation vector. This is the idea. Now the idea is, like what we were telling earlier, suppose I block this point. If I block this point fully and then do modeling, what will be my model? then I run the modeling algorithm. What will be in the model, final model? What is the best possible model? R inverse P. R inverse P. R inverse P is the best possible model. Okay. So now I am saying upper part is fully blocked. Means whatever sound is produced by the loudspeaker is never reaching the microphone. Now what will be the model? What will be the model value? Means what is, instead of 232, what will be the value there? Instead of 232, what value should come? 0 should come. Correct? Because there is no correlation between X and D. X and D are fully uncorrelated. So you create a system and you are doing modeling and you are getting 0 output, you should not be unhappy. That might be because your input and your output are fully uncorrelated. Fully uncorrelated. Okay, fine. Now we go into the case where it is fully blocked, but this mic is picking some other sound which is not correlated with the input X. Now what will be the model? Are you getting what I am? Still it will be 0 only. Still it will be 0 only. Why? Because as far as the model is concerned, X and D are uncorrelated. But D contains one signal which is independent of X. It is independent of X. Understood? So now you are getting my point or not? Now what magic is going to happen? I am telling you magic is going to happen. Now suppose there is a slight leak here. Slight leak here. Some part of the sound is reaching the mic, plus an uncorrelated sound is reaching the mic. Now what will happen? Model is now not 0. Model is something. Model is something. But what will be the error? Error will be what? Error will be what? Because what can modeling do? Modeling can only minimize energy from D, remove energy from D using signals which are correlated with X. So the uncorrelated component which is there in the signal can never be removed. So my error will be equal to the uncorrelated component. This is a very important point. You have to understand this, and this is the only thing you have to understand in this entire session, or maybe in the entire FD. The only thing you have to understand. Okay, because that is a kingmaker concept. Kingmaker concept means your life is affected every day because of this concept. I am saying every day, every minute, every second, now also. What is you have to understand? Okay, no need to take headache. Okay, there is no examination for this. Okay, what I am saying, we have to let's undo everything. What is my objective? My objective is to do system identification. Is that clear? Clear? What is the system here? The speaker and the mic is the system, or this room is the system. Understood? So I want to find out which is the equivalent filter for this room. That is what I am trying to find out. So I said I will generate a signal into this room and measure it somewhere. So what is getting inputted? X is the random input which is getting generated. What is measured? D is which is measured. What is D? It is the response of the system. System's input is X, system's response is D. Now what I want is I want to create a controller or a filter which is going to behave like this room. So what I do? Same input which I gave to the speaker, I give it to this unknown model or filter, which may have random value of weights or which may have 0 weights or some weights. What will the system do? The model also will create some output, but the output of the model and output of the system will not match because you never told that you should match. Correct? So what I do, I find the difference between the response of the system and the response of the model, and tell the model you better learn. Correct? Using what? Using a minimization of an objective function. That objective function is the expectation of t square, and then we derived and found that the best possible learning you can get, or the best possible vector of filters which I can get, is given by R inverse P. R inverse P. Did we get that? Did we get that? Is that clear? That means the best possible model you can get, best, the ultimate best possible model you can get is given by R inverse P. That means it is dependent on the correlation between x and t. Correlation between x and t. Is it clear? Now we said the next extreme condition that path is broken. Now when path is broken, what happens? X and t are fully uncorrelated. So whatever modeling you do, model will give you zero output only. Zero output only. And error will be zero only. Because there is error will be zero only, because this mic is not picking any sound. And this model is also producing no output, because model weight is zero. Multiplier values are zero. Okay, understood. Fine. Now we have a situation where the path is fully blocked and the mic is picking an uncorrelated signal. What will happen to the model? Model is still zero. Model is still zero, but D is not zero, because D contains some signal which is uncorrelated, and E contains what? E contains what? D minus Y. Y is zero, which is D. That means the uncorrelated signal is remaining there in the error. Error is not zero. Error is the uncorrelated component. Okay, clear? Now the third best case scenario is some leakage is there. Some leakage is there. So what will happen? Some signal is coming in D, okay, which has some component which is correlated with X. So D contains two parts now. D contains a component which is correlated with X and an uncorrelated component is there. Now if I do modeling, what this model will try to do? From D signal has two parts. One correlated part and one uncorrelated
It
part.
will choose less.
D will remove the, sorry, yes, Y will remove the correlated part and the uncorrelated part will remain as such. That means this fellow is able to remove energy from some signal based on signals which are correlated to the input of the model or input of the filter. This is the point. This is the point. This is big point. Because finally everything is based on correlation. That is what we are. Everything is based on probability and random process, whatever is there. That is the big thing now. Because the entire machine learning is random process and probability. This is random process and probability. Everything what we are going to do is all random process and probability. Is that clear now? Fine. Now let us case a use case scenario here. Not an ANC problem. Suppose you are talking to somebody on phone in a market. What will you do? So you don't go to market, or there is no market here. In Gandhinagar there is a market. Here market is not there. Market is there. Go to market. You don't go to market. Everything is online only. Everything is big basket. You go to market. Assume that you have got. Assume that your HOD is calling you. You have to talk. Your job is at stake. What will you do? You cannot run away from the market. You have to talk from within the market only. So what do you do? You keep it like this, keep the hand like this and speak. This is what you do. Correct? So there is a mic here. What the mic will pick up? Your sound plus the surrounding noise. Both have been picked up, and your HOD now knows that you are not in the class. You are in the market. Job is gone. This is the situation. Now, can I do noise cancellation based on what we have studied now? It is not ANC. I am not saying about ANC. I am saying about noise cancellation. Can I do based on this idea? If you are able to formulate, then the entire idea of this is clear. Can I formulate it?
कॉफी को सर कॉफी आवाज आपको जो हाल
Situation. You have a phone has a mic here, and this mic is picking up signal plus noise. Now can I remove noise from here? Can I put a filter, high pass, low pass filter and remove the noise? Can I put a high pass, low pass filter or something like that and remove the noise? No. Because what is the noise? Somebody else speaking. Same band. So it's an in-band noise. So I can't put any normal filter and remove it. Correct? But I want to do noise cancellation. What to do now? Can I use some concept from what we learned now? So suppose I put a second mic on the back side of the phone. It is there in your phone. I have put a second mic on the back side of the phone. So now I am changing my design. And I am saying that I have M1 and M2. So what will M2 pick? M2 is here. We are talking like this. What will M2 pick?
Okay.
Noise. Is this noise and this noise same? No. They are different.
Yes.
Correct? So, first mic is S plus N1 and this is N2. So, you cannot do a subtraction. Correct? Because one mic is here, another mic is here. This noise and this noise are not the same. But are they correlated? That noise N1 and N2 are not same. Is N1 and N2 correlated? Yes, because N1 and N2 are produced from the same source. N1 and N2 are correlated. Now can I use that idea to remove the noise from here? This is the controller.
Hello. जुड़ी मैडम को कुछ
What did I do? What did I do? I said I take the second mic input and give it to a filter or a controller. Controller will give some random output. I am finding the difference between those two signals. So I will get some sort of an error signal. And I tell the algorithm to minimize it. How minimize it? By updating this A bits. What will the controller do? How much error can we minimize? Only signal components which are correlated to the
N1.
input. So from S plus N1, what will get subtracted?
N1.
N1 will get subtracted because N2 and N1 are correlated. So N2 will try to remove energy from N1 and it will not touch S because S and N has no relation. You can relate these two. These are same only. See what I am saying? This signal is N1. This signal is N2. This fellow contains S plus N1. S is the uncorrelated component. So what this filter can do? Filter can only remove simple. There is no machine learning here. There is no CNN here. There is no LSTM here. It is just some n number of multipliers and adders only. But because we are using the concept of correlation and whatever we learn, Wiener filter, we are able to do that. It's a simple solution. This is that. This is the main concept of adaptive filters. This is the idea of adaptive filters. Now, in an ANC problem, you have two adaptive filters. One for creating models, then after that again you minimize the error square. Okay. So what I could also do is, instead of using a linear solution was a one-shot solution which gave me R inverse P. The problem is P is expectation of X in V. That means I should know all possible X and all possible D's to find expectation. Understood? That means linear solution is not feasible. So I should have approximations of linear solution and some other course. Okay. We will do and some other FDP when we will do that. Okay. This is out of scope for us. But I could also do a gradient descent approach. What is the gradient descent approach? What do you mean by gradient descent approach? What is the shape of the error square? Parabola. So instead of finding the minimum point by taking derivative, you start at some random point on the curve and try to move in the negative direction of the slope until you reach the minimum point. That is gradient descent. When you reach the minimum point, you stop. So you see, so the new weight value, new multiplier value or controller value, new 231 vector is old 231 vector minus something. That something is derivative of the cost function by that controller value. You get an update rule like this. That is called the least mean square algorithm. This is what is the algorithm which can be used to create a model. It's only understand. So, similarly, if I do an algorithm for this, what I will be doing is, again I will do a least square minimization. Then when I derive it, I will get an update rule. What will be the update rule? How my A values are going to be changed in an iterative manner. One by step manner. How it is going to be iterated to what we are going to get over here. So I get some other algorithm which is not LMS, it is some other algorithm. Okay. Let's see, can I do it experimentally? Can I do noise cancellation experimentally? That is our first next. So what I want to do is I want to create an experiment and show that noise cancellation can work. Not in a headphone. Headphone is there are a lot of headphones are in the market. What I am doing here is what is called an active headrest system. Active headrest system means you are sitting in the chair. When you are moving forward, no noise cancellation will be there. When you are moving backward, noise will be cancelled. This is called active headrest system. Means you want to give this noise cancelling experience to people in your car, but we don't want them to wear a headphone. And we don't want to cancel entire noise also. We want to cancel noise only in the region around their head. No way to unnecessarily do cancellation everywhere. Like in the baby's case, only near the baby's head only we need to worry about. That is called active headrest system. Means you create noise cancellation in the chair or the seat and not on the headphone. This is an arrangement for that. I will explain what is this. There are 3 speakers on the back, noise 1, 2, 3. Those are artificial noise generation, like the bell. This is equivalent to the bell. Then there are 2 dots, 3 dots in front of the speakers. Those are the primary microphones. Equivalent to the clip they put on the bell. On the bell they put some sensor, no? Yeah? That is that 3. Then controller 1, controller 2 are the 2 speakers. Why 2 speakers? Because 2 ears are there and I want want to do noise cancellation for both the ears. So behind the here, like this, I put two speakers. Then I have that white color microphones which are there, which is near here, somewhere here, which will measure how much sound is there around the ear. Around the ear. This is the setup. Now, if my algorithm will work, what should happen? Noise around the ear should get reduced. But how will I know whether noise is getting reduced and how much it is going to get reduced? Okay? By measuring how much is the sound inside your ear. But how will I measure sound inside your ear? So you are telling noise is getting cancelled. How much noise is getting cancelled? How will I will tell you are telling lie. Correct? Because when you demonstrate your product to somebody and you are saying noise is getting cancelled, it's just a relative term only. I have to say this much noise is getting cancelled. So that means I should be able to measure how much sound is there inside your ear. Before ANC on and after ANC on, how much noise is there. I have to measure and show. How would I do that? This person who is sitting there is a microphone. It is called a dummy head microphone. Dummy head microphone means that person has two ears. And it's a soft ear only, you can pinch and see. It is like soft ear. And then inside that dummy head, there are mics inside the pinna. And then you can measure it. So that measurement will be similar to whatever will be the sound inside your ear when you are sitting in that chair. So we need to measure it. So this is the setup. This fellow is a microphone. It's a 5.5 lakh rupee microphone. Okay, which is called a dummy head microphone. But now I have to run the algorithm. What is the algorithm? These filter updates which are going to happen based on so many signals which are going to come. And this has to happen in real time. Why? Because how fast is the sound coming? See, the noise is coming from the backside. No, I am generating new sounds, new type of noises, and you should be able to cancel it. Correct? That means by the time the noise reaches you, I should generate my anti-noise and cancel it. So your computation of the anti-noise should be fast. How fast? Because sound is relatively slow. Slow in the sense sound is traveling only at 330 meters per second. Correct? 330 meters per second is the speed of sound. Correct? So it will take some time from the sound from start from there and reach here. But my electronic systems are very fast. So I should be able to compute all the things and find the weight value by the time the sound reaches here. So I need a powerful processor. So that the box over there, this speedboard performance real-time target machine is a processor which has a very low latency of 5 microseconds only. So within 5 microseconds, it can take the input from the mic, do the computation, give the output to the speaker, so that by the time the sound reaches your ear, new noise, the anti-noise has been produced, and your sound is going to get answered. And this algorithm is on a sibling. It is a sibling model only. But what happens is, once you create this sibling model, it is dumped onto this speedboard system. Speedboard, it has its own sibling operating system. What is the operating system? There is a sibling operating system in there, sibling real-time something. What's this? DSpace type. DSpace type only, exactly. But it is much simpler than DSpace. You don't need that so much controller, all these things are there. It is a simple model which is getting dumped on here, but again it is executed like DSpace and dumped on it. It will say code running and all of those things. But this entire system behaves like a PC. So the computer on top of that is the output of that system, not the PC's output. And then it runs the algorithm and see how it is cancelled. And you can measurement microphones because you are trying to prove something. No, you are not going to just make a product. You are trying to prove that this is going to work. So you have to use measurement microphones. So these are made of like this diaphragm is gold diaphragm. So that's why you have to pay for that gold also. Right, but this is our setup in AICTE. So these are measured out of how much noise can be offset. That means the black dotted one is when noise cancellation is off, no algorithm is running. You have some particular sound level. But when my algorithm starts running, what is happening here is 200 hertz. This was the signal before noise cancellation. After noise cancellation, it comes here. So there is some 30-40 dB difference drop in that signal level for that particular frequency. Different frequencies will behave differently, but you can overall feel that there is a noise cancellation happening in this. Then what we also do is that we use a sound level meter to also measure in a grid around the person how much noise it has. So this is the idea. So this yellow color is no noise cancellation case, where there is some particular level of sound. But the rest of the two are noise cancellation case. One is a normal ANC, the second one is what is called a virtual sensing ANC, where we can even move the noise silent zone towards the head. So you see that it's very blue. Very blue means some 30-40 dB of drop in what do you say, sound pressure level has been achieved in real time, in a real working case. If you remove the dummy head and you sit over there, you can feel that the sound has reduced. Okay, so this is the active headrest system. In principle, it's noise cancellation, ANC principle only, but no headphone. Entire system is on the chair. So you can imagine that this is like a plane seat, private jet, not normal plane, a private jet type of the seat, where you put the noise cancelling on the seat, and the person will come sit here and then go, and you chat for. Now, based on this, my one question is, have you gone to a movie theater? Anybody? Like the market question I had to ask. You have gone to a movie theater. Which seat will you select? Center. Center. Why center?
You need to screen you and sound is sound also.
Sound also. How do you? So suppose you have a movie theater and you want to give different charge to every seat in the movie theater. And you charge 200 rupees here, 400 here, 500 there, and 700. What should I do? I want to charge. And I want to say this is something magical. But there should be some scientific element also. What I should do?
Sound effect.
Okay. Is the sound reaching you same as the sound reaching you? No. Why not? Give a technical answer based on today. What has changed when I went from here to here? The transfer function. Correct? So there is a path between the speaker system and your ear. There is a different path between that speaker system and your ear. There is a different reflection also. Correct? That means every seat has a different transfer function. Can I say? Every seat has a different transfer function. There will be some transfer function which will give me the best speech quality or audio quality. There will be some other transfer function which will give me minimum speech audio quality. Visual, you already know where to sit. So you can have a weighted average of visual quality and audio quality and say that this is the premium seat. That premium seat may not be the center, some random seat, which normally people don't take. We say that is the best seat based on measurement. You may get like that. We don't know. That means I could use a modeling experience of me to actually measure and say that there are actually premium seed and say that this is scientifically proven. Measurement, these are sensor technology. Sensor technology, where we are doing modeling of that room, and every theater will have a different seat pattern. Why? Because their acoustics is different, seat arrangement is different, speaker system is different, wall paneling is different. So this measurement has to be done for every theater separately, and separate pricing pattern we have to keep. Understood? This is system. This is the application. Any doubt? I am done already. These are mostly our papers. So if somebody, not you or somebody you know who want to apply for PhD and everything are now PhD is offered 11th of 26th of March. You can do it if you want. You want to quit your job and come, you are most welcome to quit your job and come. And stipend is not that bad. Now it is 37,000 and 42,000 and these are not taxable. And you don't have to teach.